we are doing a similar lesson to the sine, but now with cosine. And what we're doing is an amplitude shift. Okay? So I drew your basic cosine graph. Starts at 1, 90 goes to 0, 180 goes to minus 1, 270, 0, 360 to 1. Okay? And what we're going to have a look now at y equal minus 2 cosine theta. And I thought I'll do it in a table now. Maybe it will make it a bit more clear. Okay? So I've written these special angles. Very, very important. Every time you come to draw a graph, start with these angles. Okay? So cosine theta, when theta is 0, we say that's 1. When it's 90, it's 0. It's minus 1, it's 0, and it's 1. Now, what happens if I try and look at y equal minus 2 cosine theta? Let's use the same color. Okay, so y equal minus 2 cosine theta. Y equal minus 2 cosine theta. Okay. So all we got to do really is multiply each one of those by minus 2. So the 1 will become minus 2, the 0 will stay 0, minus 2 will become 2, 0, and minus 2. And then, this is probably what I should have done in the beginning, before I do the graph. But anyway. So, and then just do it on the graph. So at 0, minus 2 cosine theta will be minus 2, 0. So I'm starting from here. At 90, it will go back to 0. At 180, it will go to 2. So 2, let's say, is here. At 270, it will go back to 0. And 360, it will go back to minus 2. So you can see now I've got these little points, and all I got to do is draw a graph. Okay, so we're going to make a nice curvy graph going through all these points, and we're going to get the graph I wanted. Okay, now let's have a look at this graph. First of all, the amplitude is bigger. Okay, the maximum value is 2, the minimum value is minus 2. So the amplitude, okay, I'll just write amp, okay, is the maximum 2 minus the minimum minus 2, the time half. Okay, we learned that a couple of lessons ago. So the amplitude is 2, and we already noticed that number 2 in front of the cosine tells you the amplitude is 2. So you didn't even have to do that. The second thing we noticed that this graph, this red graph, is also flipped compared to the blue. The blue starts going down, and then it goes, and then only it goes up, where the red goes up, and then goes down. It's flipped. You remember what made it flip? Correct, it's that minus. That minus flips it. Okay? And then the last thing really I need to say about, the period is the same. Okay? The period, we start from 0, we end up at 360, just where we started. So the period is 360, so it didn't change the period. That's important, because later we're going to see cases where the period changes. And then I think the last thing that I need to say, another term that I didn't use before, is stretch. By making the amplitude bigger, in fact by doubling it, the amplitude went from 1 to 2, we stretched the graph. But we didn't stretch a graph like that. We stretched the graph like this, right? We took that graph and we stretched it in the vertical direction. So we also call these change in amplitude as vertical stretch. Now, when I say vertical stretch, it's a bit not always right, because in this case we actually stretched it. But if you remember in the sine graph we had before, we could actually compress it. We made it smaller. So that's also kind of a stretch. It's a negative stretch. Okay? So I'm going to just pause that and maybe summarize everything we learned in these lessons. Okay. So got rid of the graph and just wrote in a function. Y equals sine x. It will also work with cosine x. All our graphs are basically a sine or cosine time a certain a, which is a number. Now, let's summarize what we learned. If that a is larger than 0, then it's like normal. It's a normal graph. Like y equal 2 sine x. It starts up and then it goes down. If a is smaller than 0, in other words, there's a negative sign, okay, then what happened to the graph? It got flipped. It's a flipped graph. like y equal minus sine x. So instead of going up and then down, it goes down and then up. Okay, so the sign tells you if it's a flipped or normal. Okay, that's the first thing. The second thing is, I'm going to draw it here. If a is larger than 1 or a smaller than minus 1, then what we did, we did the vertical stretch. We stretched it, made bigger. The amplitude got bigger. Like y equal minus 3 sine x. It's flipped, okay, it's flipped, but it's also stretched, okay? We call it a vertical stretch. If, on the other hand, a is between minus 1 and 1, for example, y equal half sine x, then what happens when we had half? Everything got shrunk. The amplitude went from 1 to half. The graph got shrunk. So we'll call it a vertical shrinking. Okay? That's just a word I think I made up. I don't think you can really call it like that. Vertical shrink. Okay? Right. Okay, now is the time to solve some problems. Okay? You please check your answers there. That works out. And actually it's quite fun. Trig graphs are actually quite fun. Okay? If there's any problem, just let me know on the WhatsApp. Take care, guys. I'll see you in the next lesson.